So far in this unit, we've talked about things that you don't need to use your calculator for. Naming ionic compounds and writing formulas of ionic compounds. We've talked about compounds in general, no calculator. We've talked about drawing Lewis structures of compounds, no calculator. Now we're going to finish up this unit with some things you need to use your calculator for. At least I would need to use my calculator for it. We're going to talk about, for compounds, something called molecular weight, that's MW, formula weight, that's FW, and then using molar mass for compounds. Molar mass might seem familiar because we talked about molar mass for elements, and we're going to kind of build on that to now molar mass for compounds. So starting with MW, MW stands for molecular weight. And there are some terms in physical science that you're like, oh, well, that makes sense. It's the weight of one molecule. But now remember, we said the molecule is specific for covalent or molecular compounds only, covalent compounds. Okay, so this would be how much a molecule weighs. Now, we talked about how much an atom weighs, and if I were to ask you what units we used for how much an atom weighs, you would say AMUs, atomic mass units. This sort of problem is not too hard at all. Basically, we just add up all of the the mass of all the atoms together to make that go together to make that molecule. So molecular weight and formula weight are very similar. It'd be like blink and you miss the difference. Of course, formula weight refers to formula units refer to a repeating unit, that's an ionic compound. So a formula weight must be talking about how much it's referring to ionic compounds, and it's if you were to isolate one repeating unit, how much would that weigh? And again, basically, you just kind of add up the mass of all of the units. Mass of all of the atoms. So since the atoms, we use atomic mass units to say how much an atom weighs, so also we use atomic mass units to say the formula weight of an ionic compound. It's kind of a little bit semantics, but as it turns out, there is a relationship between molecular formulas and formula. Anyway, if you have a molecular weight, it's also a formula weight, but a formula weight is not necessarily a molecular weight. So let's do an example. So let's pick on hydrazine. We've got one nitrogen atom and 4 hydrogen atoms, and we just need to know how much a molecule of hydrazine weighs. So of course you're going to have a periodic table to work this. And you'll go to the periodic table and look up how much a nitrogen weighs, and it weighs 14.01. You'll look up how much a hydrogen weighs, and it weighs 1.008. Of course, how much an atom weighs is in atomic mass units, or AMUs. So then we simply need to take how many nitrogens there are times how much each nitrogen weighs, plus how many hydrogens there are times how much each hydrogen weighs. Okay, so now rounding, we've been about, I've tried to emphasize round correctly, round correctly, round correctly. As it turns out, these numbers of 2 and 4 are exact numbers. There is uncertainty in these masses, and then we kind of think of, it kind of, to me, comes down to, since we're adding, rounding according to decimals. So we have 2 decimals here, 3 decimals here, so we are only allowed 2 decimals in our answer. So a molecule of hydrazine weighs 32.05 AMUs. Not so bad, huh? And makes sense. You just add up those, 6 atoms, and how much they weigh, that's how much the molecule weighs. Well, let's switch gears, and the fact that this formula of this particular compound has a metal, okay, means that this is an ionic compound. Since it's an ionic compound, we must be talking about a formula weight instead of a molecular weight. So we're going to work this problem too. Just remember that I'm going to ask this in the form of a question. How many oxygen atoms do we have here? We definitely have 6 oxygen atoms because we have 2 of these NO3 units. And we have 6 oxygens and 2 nitrogens, and of course just 1 calcium. So this takes on a very similar pattern to what we looked at a minute ago, and it looks like this. The decimal number for calcium, 40.08. The decimal number for nitrogen, 14.01. The decimal number for oxygen, 16.00. So that's where those decimal numbers are from the periodic table, how much one of those atoms weighs. And then the other number is how many there are of them. So not too bad. We're going to have to round to, since we're adding, so the last thing we do, we need to round according to decimals, and it looks like we have 2 decimals in everything, so you need to round, in each term I should say, so we would need to round to 2 decimals. So 164.10 AMUs would be, if you were to isolate 1 repeating unit of calcium nitrate, that would be how much it weighs. That's its formula weight. And then we're on to an assignment slide. Dun, dun, dun.